أخبار اليوم.
Hello, dear students of the secondary stage, especially those that study in language schools and experimental schools. We have here a model for physics for third secondary. We are going to discuss the questions and the answers and how to find the answer in a very quick way and very easy way. Let's revise some information about every question when we discuss it. So the first question here we have, choose the correct answer. One of the sources of continuous spectrum is, so we are looking for source of continuous spectrum. Source of continuous spectrum. We have four choices: neon lamp, fluorescent lamp, tungsten lamp, and ruby laser. Which of them is correct? Neon lamp and fluorescent lamp, they are atomic. They are atomic spectrum. They are line spectrum, not continuous spectrum. Yes, tungsten lamp is a glowing source, so it gives a continuous spectrum. So the answer here is tungsten lamp. Of course, ruby laser is a monochromatic source of radiation. The second question, the diode is the p-n junction, as you know, as an electronic component. And we have a classification for the electronic components. First, classified as simple, complex, and specialized. And second, classified as passive and active. And here in this question, we joined the two classifications together. So, what do you think? Is it the diode, the p-n junction? Is it simple and active, simple and passive, complex and active, complex and passive? Yes, the perfect answer is complex and passive. The third point, or the third question in this part, in the circuit shown, as you see on the screen in front of you, if the battery current is I, so the battery gives the current I, the ammeter reading is, does it read I over 2, half I, or third I, or quarter I, or fifth I? Which answer is correct? So you have to pay attention, because such questions too easy, but sometimes you are in a hurry, so your answer may be wrong. So keep quiet, try to follow the steps, and you are going to find the correct answer. So here we have a current I. That's good. And this current will be distributed into two parts, I1 and the I2. And the I2 here will be distributed another time into two parts. So, first of all, we have two branches. That is a branch, and that is a branch. And when we divide the current between two branches, so we divide them inversely to their resistance. So here we have R, we have here 1.5 R, 1.5 R. So here we are going to put 3 over 5 I in this branch, and here 2 over 5 I in this branch. And then 2 over 5 I, when passing through this R, will be divided again into two parts, two equal parts. So here we have 1 over 5, and here we have 1 over 5. So the correct answer is I over 5/5. The current will be passing through the ammeter A. The fourth point here, what quantity decreases when a photon of X-rays collides with a free electron? So, photon of X-ray, free electron, that is Compton effect. You know that, Compton effect. So what decreases? What decreases? You have to underline. You have to underline each important word. So decreases is a very important word here. Is it the photon mass, photon speed, photon wavelength, or electron energy? Which quantity decreased in this situation? Yes, right. The answer is the photon mass. The photon mass decreased when the photon of X-ray collides with the free electron, because the frequency of the photon decreased. So the mass decreased according to frequency. The fifth point, there are two straight parallel wires. Each carries a current I. If the current intensity through each wire is doubled, so each wire, we have two wires and the current through each wire is doubled, and the distance between them is reduced to half. Very important words. So double for each current and distance between the two wires is halved. What happens to the force between the two wires. Would be constant or doubled or increase 4 times or increase 8 times. If you remember the relation used in this case between two wires, F equals mu, yes, I1, I2, L over 2 by D. So very quickly, this current is doubled, this current is doubled. So they, when they are doubled, they increase the force 4 times. And the distance is reduced to half, so that increases the force to double. So double for the distance, double for I1, double for I2. So the answer is increases 8 times. That is the correct answer. Let's move to the part B from this question. Question 1. Explain how you can demonstrate mutual induction between two coils. We have here an experiment. Explain how you can demonstrate means he needs an experiment. Draw a diagram for the used electric circuit. I have a word for you. When you have a question like this, so you have more than one question, more than one required. So you have here to explain, you need to underline and to draw a diagram, because you need to, before leaving the exam room, you have to make sure that you've answered all the questions. So as you see, number them, circle them, underline them, to be sure that every question, every detail is answered in the question. So that is experiment, very simple. If you remember, we get primary coil and we may connect to it a cell and a switch. You can do that. And another coil, which is called secondary coil, and connected to a galvanometer, and that galvanometer having 0 position at the middle. So at the moment of switching on, here we have momentary deflection in the galvanometer. As the switch is turned off, there is a momentary deflection in the opposite direction, indicating an EMF and current induced in the secondary coil due to variation in the current intensity in the secondary coil. That is a very simple experiment, and it is already in your textbook. And the next question, mention the scientific principle. Underline the important words. Very, very important scientific principle, the idea. What is the idea of the operation of the electric motor? Yes, it is based on the torque that acts on a rectangular coil carrying an electric current and placed in a magnetic field. So you need, don't write down just the word torque. You need to complete the sentence. Torque acting on rectangular coil carrying an electric current and placed in a magnetic field. The second point here, storing the liquefied gas. What is the idea? What is the principle? Of course, the liquefied gas is stored in Dewar's flask, but the question is not like this. It is the idea. So storing liquefied gas based on, yes, right, preventing the transfer of heat from outside to the liquefied gas by conduction, convection, and radiation. The last point here, using laser in the reconnection of retinal detachment. Of course, you know that sometimes happens retina detached from the underneath layer. So what is the idea of using laser? Yes, right. The thermal effect, that is the question. The thermal effect of laser can cauterize the retina to the underneath layer at the point of detachment. And we have here a problem at the end of the question. Number C is always a problem. A monochromatic light of wavelength 400 nanometer, so that is wavelength. And we need to convert it into meters, so multiply, yes, right, times 10 to the power -9, is incident on cesium surface if the work function, yes, work function is EW. As you read, as you see me, as you read, write down the sample conversion, and the work function here is 2.1 electron volt, and this should be converted, that is unit of energy, electron volt, remember that. That is unit of energy should be converted into joule. And to convert it, so multiply, so 2.1 multiply 1.6 times 10 to the power -19. This way, we converted it into joules. So that is the given. And the first thing here, the first question, to find the linear momentum of the incident photon. The second question, to find the maximum velocity of the emitted electron. And finally, the wavelength associating the emitted electron. So let's see or have a look at the answer. Linear momentum of the photon, linear momentum of the photon. You can calculate it by, yes, right, h nu over c, or e over c, or h over lambda. So here we are going to use h over lambda, since the wavelength is given in this problem. And as you see by calculation, it gives 1.65 times 10 power negative 27. And the unit of linear momentum, take care of that, kilogram meter per second. The second part is to find the energy of the photon. You need to know whether the energy of the photon is higher or less than the threshold frequency or the work function of the metal. So energy of the photon equal h multiplied by c over lambda. By calculation, you will find that the energy of the photon incident on the cesium surface is 4.95 times 10 power negative 19 joule. Yes, it is greater than the work function. And subtracting the two values, energy of the photon minus work function, you obtain kinetic energy, and then kinetic energy is half mv squared. Finally, we can obtain the velocity of the emitted electron. It is 5.9 times 10 to the power 5 meter per second. Take care, that is very important here. That is the wavelength associating the electron, not the wavelength of the photon. So here lambda, but it is completely different. That is the wavelength of the photon, but this is the wavelength associating the electron. So you have to read the question well. And as you see, de Broglie equation, lambda equals h over mv. By substitution, we obtain that 1.23 times 10 to the power negative 9 meter, and that is the end of the first question.